Welcome to Pivot 2023 and our next two sessions titled On Solid Ground, Addressing Induced Seismicity Challenges. I'm Katie Smye with the University of Texas Bureau of Economic Geology, where I co-lead the Center for Injection and Seismicity Research. In these two sessions today, we're thrilled to bring you a set of three technical presentations, followed by a panel discussion with four subject matter experts, all on the important topic of induced seismicity. Before we dive in, I'll take just a few minutes to orient us for the sessions ahead, thinking about what induced seismicity is, why it matters, and how we as geothermal and oil and gas communities can think about and communicate about induced seismicity, hazard, and risk. So as we start to think about these things, we're going to drop a poll on the platform. The question is, how do you feel about induced seismicity risk in the geothermal context? And you should see that poll and the answer options there. We'll come back to results of this poll. We'd love to hear your thoughts, and we'll discuss it further when we get into our panel discussion in the second session. In the meantime, when you think of the topic of induced seismicity, that is earthquakes caused by anthropogenic or human activities, a range of examples might come to mind. Do you think of the recently reported Swift quake created during a Taylor Swift concert, reported to be the equivalent energy release of a magnitude 2.3 earthquake? Or maybe fan quakes created during Seattle Seahawks games? Or do you think of examples of brittle failure of faults in the Earth's crust, like the magnitude 5.5 earthquake in the Pohang Field in South Korea, or the earthquake clusters in Basel, Switzerland, both associated with geothermal energy production? Or maybe you think of earthquakes associated with gas extraction in the Groningen Field, or oil field wastewater injection in Oklahoma and Texas. In the context of energy extraction, small earthquakes are happening every day as humans interact with the subsurface of the Earth, in geothermal and in oil and gas production and in water injection, and almost certainly in the future with CCUS and even hydrogen storage. The vast majority of these earthquakes are too small, below a magnitude 2.5 or 3, to be felt at Earth's surface, and therefore they go unnoticed by all but seismologists who are monitoring and analyzing them, and by researchers like those we'll hear from today who are studying them. So why do they matter, and why are we devoting two full pivot sessions to this topic? Well, induced earthquakes, including both large and small events, matter for several reasons. Small earthquakes give us interesting and useful information about the reservoir and how it can be effectively and safely managed. They might tell us how far fractures have extended, how much pressures and stresses have changed. And when they align and organize along planes, they can tell us something about the faults on which they occur and the stresses acting upon those faults. And when earthquake data is analyzed in this context, it can provide insight into the mechanics of fault rupture in the presence of anthropogenic activities. This is all extremely useful information for understanding the subsurface and managing the reservoir. But induced seismicity also matters because not all induced earthquakes are small. And if we want to be responsible producers of energy and stewards of the earth, the environment, and nearby communities, we need to work to mitigate the effects of large magnitude events. Felt events have the potential to threaten geothermal development more broadly if projects are halted. And induced seismicity matters in part because public perception matters. So how can we think about and talk about the issues of induced seismicity and geothermal? These are the things we'll dive into today. But firstly, we can frame the very real risk of induced seismicity by acknowledging it and taking it seriously and showing we've learned from prior experience. And secondly, as a community, we can operate with openness and transparency. And this is where researchers, regulatory agencies, NGOs, and energy producers can come together to develop things like open source data sets and platforms on which to share them, cohesive and integrated in seismicity plans, and robust site characterization efforts, all of which not only signal that the risk is being taken seriously, but also are part of the hard work required to prevent and mitigate earthquakes to the best of our ability. So these are all things I'm looking forward to hearing more about from our presenters and our panelists today. Let's dive into the technical portion of our induced seismicity session. The idea here is to hear from experts in the field who can provide us with a strong technical baseline with which to understand the challenge of induced seismicity in geothermal systems.